Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0971, indicates an issue with the Pressure Control Solenoid C control circuit, specifically flagged as high. This error is noted in Honda's continuously variable transmission, CVT systems, from the model years 2017 to 2022. The code suggests an electrical problem, rather than a mechanical one, within the transmission, which means that a thorough check of the wiring, solenoid, and related components will be necessary. The Pressure Control Solenoid C manages the hydraulic pressure within the transmission, using signals from the Powertrain Control Module, PCM, to regulate performance. Being located in the valve body assembly of the transmission, it's crucial for proper operation. Typically, a high circuit voltage can indicate a faulty electrical connection or wiring issue, leading to inaccurate solenoid performance, impacting the overall drivability of the vehicle. DTC P0971 signifies an electrical circuit malfunction affecting the Pressure Control Solenoid C. This solenoid plays a critical role in the vehicle's continuously variable transmission, CVT, by managing hydraulic pressure, which directly influences the transmission's ability to shift gears smoothly. It's positioned within the valve body assembly of the transmission, making it integral to the functioning of the drivetrain. Given that this trouble code is related to an electrical issue, mechanical failure within the transmission is ruled out. The presence of high-voltage signals can be a symptom signaling a fault in the wiring or connectors associated with the solenoid. Therefore, rigorous checks of the electrical components surrounding the solenoid are paramount to diagnose and fix the underlying issue. The potential causes for DTC P0971 are primarily centered on electrical failures. As highlighted in the diagnostic text, one possibility is a shorted wire to power, which means that the CPC-LS wire may become inadvertently connected to the power source, causing excessive voltage levels. Another potential issue is an open circuit in the wiring leading from the solenoid to the Powertrain Control Module, PCM, which could interrupt the effective communication line essential for solenoid function. Additionally, a faulty Pressure Control Solenoid C itself could be to blame, leading to improper voltage readings. Since this error code does not indicate any mechanical issues, the troubleshooting will primarily focus on these electrical components and their integrity. When DTC P0971 is present, the vehicle may exhibit several symptoms indicating potential transmission problems. These can include erratic or problematic gear shifts, where the vehicle may experience slips or delays during acceleration. Additionally, drivers may notice that the transmission doesn't respond as expected, which can lead to unsafe driving conditions. The illumination of the check engine light on the dashboard is another common sign, prompting drivers to seek further diagnostics. With such symptoms, it becomes vital to address the DTC promptly to prevent further complications and ensure the smooth operation of the vehicle's transmission system. The first step in troubleshooting DTC P0971 involves basic verification procedures. Begin by turning the vehicle to the on mode, a necessary action that powers the onboard diagnostic system. Following this, using the Honda Diagnostic System, HDS, clear the stored DTCs to reset the system and eliminate any temporary faults. After clearing, start the vehicle's engine, allowing it to idle for at least 1 second. Finally, check for any pending or confirmed DTCs once more to determine if P0971 persists. If the code reappears, it confirms a repeated failure, allowing you to proceed with further diagnostic steps. Step 2 necessitates conducting a detailed check of the CVT clutch pressure control solenoid valve. Begin by turning the vehicle to the off lock mode to ensure no power is flowing through the circuits. preventing accidental damage during troubleshooting. The next action is to jump the SCS, Service Check System line, with the HDS, allowing for testing without interference from potential external variables. It's crucial to wait a minimum of 1 minute after this action to protect the PCM, Powertrain Control Module. After the wait, disconnect the PCM connector C, which contains 51 pins. Measure the resistance between specified test points on the PCM. A reading between 4.7 and 5.9 ohms indicates the solenoid is functioning correctly, while any other readings suggest further investigation is warranted. In the third troubleshooting step, you will inspect for shorted wires in the CPC-LS line leading to power. First, disconnect the solenoid wire harness A8P connector, which allows for a safe inspection of the electrical configuration. With the vehicle now in the on mode, you will measure the voltage across 2 designated test points within the disconnected configuration, ensuring that you are specifically testing wiring integrity without interference from the solenoid circuit. If you find voltage present at the test points, this confirms that there is indeed a short to power in the line, and repairs or replacement of the damaged wiring will be necessary. Conversely, if no voltage is detected, the CPC-LS wire is likely intact, and you can move on to the next step. Step 4 requires an analysis of the continuity of the CPC-LS line. Start by ensuring that the vehicle is turned off, lock mode, to establish a safe test environment. With the solenoid wire harness A8P connector and the PCM connector C both disconnected, check for continuity between designated test points. This procedure ensures that the electrical path is uninterrupted, which is vital for the solenoid's operation. If continuity exists, proceed to the next troubleshooting step, confirming that the wiring is connected correctly. If continuity is not present, an open circuit in the CPC-LS line must be repaired, ensuring the complete electrical path is restored for optimal performance. During the 5th troubleshooting step, the focus shifts to examining the ground 1, GND1, and ground 2, GND2, lines for continuity. To begin, disconnect the PCM connector B, which also contains 51 pins, allowing you to access the electrical ground connections safely. Checking continuity between the specified test points requires the vehicle to remain in the off-lock mode, as this prevents any electrical flow during testing. If there is continuity between the connections, it indicates that the grounds are intact and you can continue troubleshooting. However, if no continuity exists, repair efforts must be directed at both the GND1 and GND2 wires between the PCM and body ground to ensure a reliable electrical grounding system for all respective components. The 6th step focuses on the internal resistance of the CVT clutch pressure control solenoid valve, requiring greater disassembly. Start by removing the valve body assembly to access the solenoid for a direct analysis. After gaining access, disconnect the CVT clutch pressure control solenoid valve 2P connector. This allows for an uncoupled measurement of resistance. Ensure the vehicle remains in the off-lock position during this process. Measure resistance across specific test points on the disconnected solenoid valve. Acceptable readings will range from 4.7 to 5.9 ohms. If values fall within this range, it confirms that the solenoid is functional, and attention can then turn to potential issues in wiring or the PCM. Conversely, if resistance is outside this range, it indicates a faulty solenoid valve. Replacement of the valve body assembly will be necessary. In the 7th troubleshooting step, the emphasis is on checking the CPC dash line for continuity. Ensure the vehicle is in the off-lock mode to mitigate any electrical risks during the inspection period. Using the same approach, check continuity between designated test points with the lower valve body removed and relevant solenoid connectors disconnected. This process is crucial for verifying the CPC line's integrity, as it creates part of the operating circuit for the pressure control solenoid. A finding of continuity indicates that the wiring is intact in its path back to the body ground. If continuity does not exist, it signals an open circuit, necessitating repair of the CPC wire between the solenoid and body ground to restore proper function. The final troubleshooting step involves checking the continuity of the CPC Plus line to ensure the entire system operates correctly. Begin by ensuring that the vehicle setup is in the off-lock mode, fostering a safe testing environment. Measure continuity between the specified test points to ascertain the connectivity of the solenoid wire harness B and the solenoid valve connector. The continuity check will determine if the wiring is intact within that section. A successful continuity reading indicates that further examinations may be required elsewhere in the circuitry. However, if continuity is absent, repairs must focus on the CPC Plus wire, addressing any breaks between the harness and solenoid connections to guarantee proper electrical signals for the solenoid's operational integrity. Once repairs are executed based on the outlined troubleshooting steps, it's essential to verify that all repairs were effective. The initial action should be a comprehensive test drive of the vehicle under varying driving conditions to evaluate the functionality of the transmission. During this drive, monitor shifts, responsiveness, and overall performance to ensure all symptoms related to DTC P0971 have been resolved. After the driving test, utilize the Honda Diagnostic System HDS to recheck for any remaining or new DTCs, confirming that the system is clear. Lastly, ensure that all electrical connections and connectors are securely fitted, as loose connections can result in recurring issues leading to further diagnostic trouble codes. To prevent recurrences of DTC P0971, implementing routine maintenance strategies is crucial. Regular inspections of wiring and connectors can help catch potential issues before they escalate into serious problems. Maintaining proper transmission fluid levels is another vital action, as low or dirty fluid can compromise overall performance and lead to faults within components like the solenoid. Moreover, keeping solenoid connections clean and free from corrosion or debris ensures that electrical signals flow unobstructed, which is vital for optimal transmission operation. Adhering to this preventive maintenance will prolong the life of both the transmission and associated components, ensuring dependable performance over the years. In conclusion, DTC P0971 revolves around electrical anomalies affecting the Pressure Control Solenoid C control circuit. Given that the code is not indicative of mechanical failures, focused diagnostics on the solenoid, associated wiring, and connectors are essential for effective repair. Throughout the troubleshooting process, varying methods of testing both continuity and resistance ensure comprehensive checks of the electrical components. Implementing preventive measures post-repair further enhances the longevity of the transmission and its components. Finally, confirming the effectiveness of all repairs through drives and rechecking for DTCs guarantees that the issue has been resolved, providing peace of mind for both technician and vehicle owner alike. Please like and subscribe to the channel. See you next time.